Okay, good evening again. And of course, the case studies with custom linting. This is, I would say, personally a good favorite because we are kind of when you code and when you use the linter, and then you see what's going on there. So you're actually seeing it. So it's all the more kind of interesting personally to me. Um, yes. So the uh, what happened? Where am I losing? Let me just. Sorry, I went too fast. Okay, so the open source, this is all about test bench linting, and then we understand that it is old and proven concept. The code analysis, this approach is the changing, and it provides flexibility in terms, and we can customize the options. It's also the BYOL concept, wherein we build our own linters, wherein we have a set of minimalistic rules. Either we customize our rules based on the requirement, or we customize it for the customer who would want us, who tells us the issue, and then we would go ahead and write the rules for them. So this is something that we build as we go. And then the APIs allow custom applications. So some of the good parsers here is variable, which is C++ based. Then you have the SV Lint, which is a custom plugin, and it's also Rust based. The PySlint, which is the Python based, works on top of Slang and PySlang. So the case study one. So if you see this, I think a lot of familiarity here. So in case while system verilog is calling a C function, and then a simple example on the top left corner, wherein there is a modulem data, and we are trying to import this DPI function. And there's an integer called csum, and it has integers which is f1 and f2, and so on. So here, what is the PySlint? What is it saying? The compact DPI old spec. So the basic idea here is that because it is a C is being called the system verilog, what it so when you lint on it, when you use the linter, it says that here is a problem. So we catch it early. And what is the problem? That instead of DPI, you could use DPIC because you're calling the C function there. So this is a wrong spec str in the DPI declaration. According to the IEEE 1800/2012 specifies DPIC as the spec str. Uh, I hope so far it's good. Now, the second case study is about DPI and then using the two-state variables. So, as we understand, we know that C, of course, has a native two-state support or a two-state variable, whereas in System Verilog, we use up to four states across the SVC boundary. That is where you have the X and Z also coming up. So when you lint this small piece of code, which is given as a sample on the left-hand side, you have the logic called 16-bit, and then you again import DPIC, and then you have the output data. So the linter says that on the C side, everything looks good, whereas on the SV side, why is there is a Z on the SV side? And so the violation here is called function DPI, no for state in return. And so what we are trying to tell you here is that avoid the four state variables across the SVC boundary. So the native C, rather the C as the native two state support. So of course it's easy to mess up, and why pay for the debug when we are able to PySlint it and catch it early. The third case study here is about a dist issue. So this is declared in a constraint block. So you have when you want to randomize and have multiple options, you have the 15 to 16 bit, and then the F1 where it goes from 15 beyond up to the value of 65535. So is equal to 1. So when you know that in this particular case, there is a weight assigned to everything, and when the weight is assigned and you use a is equal to colon is equal to, it specifies it assigns the equal weight Whereas a 32-bit, it goes from 0 to 31 and it shows only 32. The other one shows from 32 to a bigger value. So because the weight being assigned here is the same. So when you lint it, when your system lint, use the UVM lint, it catches and says that the PySlint violation says the function constraint dist colon is equal to. Instead of that, use a colon slash operator wherein as it assigns a specified weight to the item, or if item is in a range, to the range as a whole. So if there are values in this range, the weight of each value is the range weight by n, for example. So 0 to 31, instead of using colon is equal to, if you use a colon slash, that would be the solution there. So in the second case study, or the fourth one, with regards to the constraint precedence, so here we got a problem from this very famous, I think, is a verification software, hardware software expert called Avidan FOD. So it's really great that we were able to take that example. So he was working on a particular example where there was this selection of a value between 5 and 6. It threw a value, a big value here. As we see, the number is like 873, very big integer there. So instead of showing some value between 5 and 6, and for this person being an expert, took about 2 hours. Whereas I think anybody like us, when I say us, me or my team, anybody, it would probably take like a half a day or probably more than that. So by in terms of by linting it by using the UVM lint, what we could do is we could find out that, hey, we should not be it should be the constraint precedence which was the problem here. So which is FWEE and the question mark. There should be a number between 5 and 6. That is what we are saying. So I would like to say it here. It's post randomized. The PySlint violation here is the constraint wrong operation select priority pre potentially incorrect constraint expression. This expression involving operators with different precedence is observed here, just like how we use the BODMAS. As per LRM, equality operators have higher precedence than the conditional minus select slash mux question mark operator. So that's how if you use bracket, tick bracket appropriately around the constraint. So FOO is equal to FOO select, and then the value is between 5 and 6. So this is what we were able to figure out because of the PySlint, which was got early. Now, so going with some sample rules in PySlint, like we mentioned, these rules are also in GitHub. In the class prefix, you have the name class prefix. In the naming style checks, if you go with the description for the naming style checks, you have these many name CL prefix or CG prefix, and then ASM, and then cover prefix. So here the lint rule ID is UVM driver missing params. Driver should have REQ parameter overridden. And then you have the assertion specific performance and debug categories, wherein you have this missing label, missing end label. We have used this many times. And then there is a no pass AB, and then missing fail AB. So here the thing is, the rule which we use is the UVM agent is act hide, and UVM agent is act reuse. So the agent should check is active before constructing drivers sequencer for the reuse. We are going to see some examples also further. And the last class, rather the one of the last this thing in this list would be the class specific style functionality, where the class method not extern, missing end label, and function constraint missing cast. So this is with regard to the UVM monitor. Missing VIF monitor should have a handle to virtual interface. Now, as we were seeing here, the UVM agent is active redeclared. So what we say is that agent should not be reliquid. Usually, it is declared to see whether it's in the is active as a driver, or it should just in the passive mode to be a monitor and observe. So in this case, if you see the class HBus master agent extends UVM, sorry, UVM agent. This field determines whether an agent is protected UVM active, passive, enum is active. So if you see that UVM void, UVM object on the right hand side, UVM report object, UVM component, and UVM agent. So is active is a UVM active, passive enum. So the value of is active as declared above would be set to UVM passive. This is against the UVM standard implementation that makes it UVM active as a default. So the protected would prevent an environment class unable to access this field, a common code style other than the UVC that do not override the base class. So what's the point of using UVM agent here as base class and not a UVM component? So we should not make any mistake. That's the suggestion. And what we are not suggesting is rather questioning why this redeclaration in the user agent code. So usually the default is the UVM active as the default. So this is for the reuse issue, the UVM agent. So all these are caught while linting itself at the at early stage. So this is again UVM agent, which is not reusable, should be used to build phase to constructors members, such as the driver, sequencer, monitor, to maintain the reusability of agents. Active components such as driver and sequencer, it should be guarded by a check to the field such as is active. So, that guards the sequencer and the driver, which are the active agents. It found a UVM agent without reusable build phase packet TX agent. So here again, if you see the virtual function void build phase input UVM, so the code is being given here in this piece in the bottom, and all that it says is during the issue is about the UVM agent reissue thing here, and that's the issue. Violation is called UVM agent not reusable. Some of the case study reflections that we would like to see here on the left hand side: the UVC missing subscriber, UVM environment missing scoreboards, VIF inside the scoreboard, interface without clocking blocks, driver monitor, and the four state types in the transaction models. So the violation count by rule ID, UVM agent role not reusable is one. The interface missing CB is one. Missing coverage is one. Missing SVA is one. Missing sub FCOV is one, and the monitor is blocking two, and the missing a port, and the scoreboard no whiff allowed is one, and the check ran is one. So total number of rules checked is 95. Number of rules violated is 5 in this case. So here again, if you see UVM XN, no logic type. So the transaction models are intended to be at a higher level of abstraction than the typical HDL. Found a data declaration of logic type inside the UVM sequence item derived class. So it's highly recommended to use two-state variables in the transaction models. So more of case study reflections. Here the violation is UVM driver, no edge sync. Driver monitor should use clocking blocks to synchronize various events in the DUT, including the clock edges. This is to ensure that we avoid the race condition in the test bench code. Specifically, system Verilog clocking based synchronization ensures that a trigger event at POSH with dot clock, or at a negate clock may get triggered earlier. So it's recommended highly to use the style and not to mix it with the classical Verilog style of edge-based timing control. So at CB in brackets. So this is we found a UVM driver, my drive with negate based timing control. So if you go through this verification academy, you would be able to find this. So the violation again using UVM missing sub FCOV. So we found a UVC without functional coverage component. So UVM provides a base class UVM subscriber to model functional coverage for every DUT interface. So found 6 number of UVM agents while the number of subscribes is 0. So some of the SVA lint sample rules here for the SVA lint is that one of them on the performance category, we have the missing implication operator, pass action blocks, large delays, and excessive threads. In the debug category, we have the missing fail action block, insufficient debug information, and missing dollar sample. In the compatibility, it's VCS, XLM, Quest for VCS, XLM, Questa, ALDEC, and Formal. So in the functionality category, liveness versus safety, incorrect clocking or sampling, missing dollar rows, and degenerative SEQ. In the style category, the naming rules and the quality rules. So yes, these are some of the things like we said. We have worked on these uh, examples, and this is like a short set of what we wanted to present here. Some of the rules and UVM lint rules and the SVA lint rules, and many of it could be found in the GitHub as well as we go GitHub. Thank you. Any questions here?
Thank you very much. Okay, hopefully you can hear me.
Yes.
Okay, so thanks, Hema, for the presentation, and a lot of it was on UVM as well. Can you hear me?
Yes. 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 Sure.
Okay, great. Yeah, thank you. And